because it's not native for them. And third, feel free to call. If later on you have questions, I'm at the City of Amarillo. I'm not going anywhere. I'm glad to help if I can be any of assistance. Thanks.
Thank you very much, Rich. Our next presenter will be speaking on conserving and managing groundwater assets. Dan Haddock, he's the Director of Water Utility Services with Intera. Dan is a Principal Engineer and Director of Water Utility Services for Intera. His work focuses on helping utilities and other water users get the best performance and longest life out of water resources and infrastructure. He is a licensed professional engineer in Texas and multiple other states and former utility engineering manager. Dan is a graduate of Rice University.
All right. Yeah, I'll let you do it. Yep. I think that'll work. All right. Well, first of all, I'd like to thank the Panhandle Groundwater Conservation District in the City of Amarillo for the wonderful hospitality, and appreciate the opportunity to be able to speak with you this afternoon. My background is in utility engineering. My formative years of my career, I was an engineering manager, so involved in planning and getting stuff built and trying to get the most out of the assets that our utility had. And those of you that have worked with Intera here, you may know us best as a company that works with groundwater conservation districts or the Texas Water Development Board. My role with Intera is, as the Director of Water Utility Services, is to kind of take those tools and that expertise to helping solve practical problems that utilities have, because that's kind of the way my mind works. And that's very much related to what I'm going to talk about today. Do you know what I need to do to get the I'm just curious of the folks that are here, who's with, just curious who's with groundwater conservation districts versus utilities. Groundwater conservation districts, there are utility folks out there in the audience as well? All right, it's my people. All right, great. So obviously the smartest thing to do with your water resources is to be smart about your water use and use as little, use as little as possible. But it's also important to make the most of the resources and the infrastructure that you have. And I think a lot of folks have talked about all the investments that are going to be necessary in order to ensure water supplies for the future. And affordability is going to be a very important. It's already important, but be a very important driver in the future. Water needs to continue to be affordable. So making the most out of the infrastructure and the resources you have today, I think, is a very important first step. So let's start with some of the challenges, just in this area. As everyone here understands, it's a limited resource. Actually, declining resource, and at the same time, the region wants to grow. The challenge is that, because infrastructure is expensive, very, very expensive. And as we move to these new water management strategies, ASR, brackish water, other strategies, those are even more expensive. Infrastructure also has very long service lives. I mean, you build a pipeline, well field, expect that stuff to last for decades and to be useful for decades. The trick is to build it and manage it so that those long-lived investments, so you can get the most value out of them over their entire life. The need for those big new future investments is always going to come, but the most that you can get out of what you have today, the more affordable water is going to be in the future. So for a well field, here's some of the things that, here's how some of the conditions can change. So it's a well performance and well field performance is kind of a moving target. You've got water level trends, water levels dropping in the aquifer. You've got changing demands, and you've got loss of efficiency in the wells. The day a well starts operating, it begins to lose efficiency. So all those things together result in the well operating under different conditions than when it was first put in service. And that can result in declining yield or increased operating costs. It can also cause asset life to be shortened. If pumps start to operate where they shouldn't, they can fail sooner than they should. There's all kinds of questions, to figure out, how, what's the best way to lay out a well field, given that these conditions are going to change over the future? How often should you really clean and rehabilitate your wells to make sure that they perform adequately? I'll point out that groundwater assets are really, really unique in a way, in that it's an interrelation of these natural and built systems. You've got the aquifer system, and then you have this built infrastructure, the wells and pumps and pipelines. And the flow and water quality can also vary within a well. It's not necessarily the same everywhere down through the well bore. These interactions, the way these things interact and the way they change over time is critical to figuring out the right operation and maintenance strategies. The key to figuring this out when you have changing conditions like this is to look at your data. Utilities generally have, from my experience, the data that we had on our well fields was variable. For some we had a lot of data, for others we didn't. It's in all kinds of different formats. You've got files full of paper. You've got your SCADA systems. There's pump tests, maintenance records. There's all kinds of data available that can help you to figure out how to approach this. It's just a matter of getting it into the right format. Trick is getting it all together in an effective way that you can look at it and learn some things from it. So this graph here on the left, this is a bunch of different data that came from paper records and pump records and things like that, and it was assembling water levels, well efficiency, flow rates, maintenance records, like when maintenance was performed, to kind of look and see how that well behaved over time. And you could start to see how quickly it would lose efficiency and what trends were, and to use that information to figure out, over the life of that pump, over the life of that well, where is that thing likely to operate? Because it's going to be changing, and you want to make sure that you pick the right equipment to operate efficiently and effectively over that whole range. There's good potential for getting really good results from taking this kind of approach. We have one project for this is for a utility in the West that they have a critical well field that they use to supply ASR operations. So they bank water from an alluvial aquifer during the winter to pump out during the summer. And this well field, the problems they were having was frequently coming up short on the amount of water that they wanted to bank. Well efficiency was declining very rapidly, poor reliability, the pumps were failing, and they had all kinds of different water quality issues and air entrainment because of the way they were operating the well field. In addition to pump failures, they were also having to throttle valves and do all kinds of things that aren't really recommended. So, through this process, collecting all this data on this small set of wells, there's only about 10 wells, we were able to figure out what the optimal pumping equipment would be during different seasonal changes in water levels, kind of in between cleanings of the wells when efficiency declines, and to establish some recommended maintenance triggers to help them figure out how to optimize the yield and minimize the life cycle cost. For these particular wells, this varies from well to well, but for these, more than half, the green area on these pie charts is the energy cost. So more than half of the life cycle cost of the well was in energy. And the changes that were recommended for this well field would result in a 33% increase in their reliable capacity and reduce pump failure by having the right pumps in there that weren't operating outside of their range. And the first year after making some of these changes, they increased the amount of water they were able to store for ASR by 50%, which was a big win for them. By getting the right pumps in, they have started to save a lot of money on energy per million gallons pumped. And once they've finished changing out the pumps, they have the potential to save over $160,000 a year. And this is kind of clipped off at the bottom, but through this process and getting this data together, the operators were able to identify what data do they have that they're not pulling together that they could be looking at periodically to help them make these decisions about when to clean and when to maintain wells to get the longest life out of them. Another area where it's possible to really get more out of what you already have is in optimizing source water quality. And this is something that I think has great potential. I apologize, it's a different version of PowerPoint, I think, and some of the letters got moved around. This is, Intera works with a company called BEST and also Field Data Solutions in Texas and a couple neighboring states, Oklahoma. And what this technology is it's flow profiling. And this Dr. John Isbicki with BEST, he was the inventor of this process for the USGS that uses pulse dye tracing and water sample collection to basically collect flow and water quality data all through the well bore. And this can be done while the well is in service. So see the vent or the access pipe there. The instrument can be dropped down through there. It injects NSF approved dye and takes water quality samples as it's being pulled up. And then the analysis of that data provides a profile of how much water is coming in where on the well and what the water quality is. So if you have a certain parameter that's causing you to, say you have a well that's got arsenic levels that are increasing and you're looking at maybe having to build a treatment facility, that could be quite expensive. What's possible with this technology is to figure out, because the flow and the water quality from these different depths in the well are not the same. And if you look at the two areas that are circled there, the red lines, this is for iron. The red lines are the iron concentrations at those two intervals in the well. Those two intervals also don't contribute very much water at all. So they can be blocked off, and the iron can be reduced significantly without really affecting the yield. So this could be arsenic or TDS or chlorides or whatever it is that might be causing you to think, oh, we're going to have to blend this or treat it or do something that's going to cost us a lot of money. There may be an opportunity to go in and modify the well to avoid having to do that. Another way that this technology can be used is, that I think is important, is also just maintaining the wells. This could be used to when a well is first developed, to determine, because water is not entering the well bore uniformly, it's coming in different places. This technology could be used to test to see if a well's fully developed, and then later, when it's being cleaned and rehabilitated, it could be used to see, where the problem areas are. So, all of these things together, the analysis to optimize the hydraulics and the maintenance of the wells, looking at whether you can fine-tune tune the water quality enough just to avoid having to build that treatment plant. All these approaches are geared towards making the most out of the investments that you already have in your infrastructure, making the most out of the resources that you've already developed, and also to make smart new investments. If you're developing a new well field, you may decide to complete a well slightly differently if you find out some things about the water quality that could end up reducing your treatment costs long term. So, and this is all about, we all know there are big investments in water infrastructure that are going to have to be made over the coming decades, and all this stuff is expensive, and the newer management strategies are just more expensive. And so, again, my focus is really what I like to see utilities do is get the most out of the infrastructure and the resources that they have, because your customers need to be able to pay their water bill. So, all right, and with that, thank you. Now, I'd be happy to take any questions if there are any. Yes, sir. It depends on the well construction. The parts of the well can be blank. Parts of the well screen can be blanked off, or depending on the well construction, you'd have to make sure that there isn't another avenue for that same water to get in. Yeah. That's what you have to look at that and make sure that the well will lend itself to that. If they're separated by sufficient distance, you can get a lot of good benefit out of doing something like that. You may have to, go a little bit beyond the area that you think it's coming into. It's not going to be perfect, but the idea is just to push that water quality down below the MCL, so you don't have to spend that money on the treatment facility.